Speaking about the thymus, it's located inside of your mediastinum. Remember, mediastinum is the area located between your lungs. So your mediastinum is actually have so many different parts. You have a superior mediastinum, you have an inferior mediastinum. In your inferior mediastinum, it's subdivided into portions as well. Actually, let me just show you a picture of it because that will make it much more simple. Yep, exactly. So you can see superior and inferior mediastinum, that this portion has an anterior, middle, and posterior part. Yes? So, speaking about the thymus, it's located at the anterior superior mediastinum. A really common question in the USMLE, if someone gets his basically, oh yeah, they love this one. Let me draw it for you to know. If we say that this is your sternum, this is your sternum. You know that if you stab someone here and you break the sternum, basically, you will hit the right ventricle. Yeah, we know this. But if you hit him here at the upper portion, you will hit his thymus. Please know that. You will hit his thymus. Okay. So it's located in the anterior superior mediastinum. It's the site of T cell differentiation and maturation. We'll speak about how that occurs exactly in the future. It's an encapsulated organ again. The thymus epithelium is derived from the third pharyngeal pouch, which is an endoderm. You're like, what is endoderm and what is a third pharyngeal pouch? Don't worry about it now. We'll speak about it in reproductive. Whereas thymic lymphocytes are mesodermal in origin. Just a quick thing about endoderm and mesoderm. Basically, after a sperm connects with a oocyte, they create a zygote. This zygote will keep moving until it binds to your uterus. So, So after that happens, the next step is, oh yeah, here it is. Look at this area. So you have here your yolk sac and here you have your amniotic cavity. Between these two layers, you have an area in which it composed from 3 layers, okay? These 3 layers, each of them has a different origin. So this is basically just the zygote has bound to the uterus. So yolk sac, amniotic sac, in between you have this ectoderm, mesoderm, endoderm. The ectoderm make your nervous system, hair, skin. Your mesoderm makes multiple stuff, and your endoderm make your basically your epithelial cells. So if you take a look what they write here in first aid, they write that your thymus, which is basically an epithelial cells, comes from endoderm, yes? While if we speak about the lymphocytes, they are blood cells. So the blood cells come from, well, let's take a look. The blood cells are a portion from your circulatory system, so they come from mesoderm, okay? So cortex is dense with immature T cells. So here's the thing. The deeper you go in the thymus, the more mature you become. So medulla is pale with mature T cells and has corpuscles containing epithelial reticular cells. What you have to know that the deeper you go inside of your thymus, the more mature your T cells will become. Because the maturation of the T cells occurs where? It basically occurs inside of your thymus. Please know, it looks like a flower. This has corpuscles, which contains a lot of mature, what? T lymphocyte. Look, it looks like a beautiful flower. Here you go. So that's the Husser corpuscle. It has what? Reticular cells. So what are these reticular cells? We'll speak about their function when we reach them. But for now, know that this structure exists in your thymus. Okay? So next we have the following. We have normally neonatal thymus has this sail shaped on chest x-ray, which looks like this. It involutes by 3 years of age, but it can have persistent remnant up to 20 years, but after 20 years, you will have zero thymus. You will not have anything. It will be just fat and fibrous tissue. Absent thymic shadow or hypoplastic thymus seen in some immunodeficiencies, like severe combined immunodeficiency, which is a dysfunction of both T and B cells. So in SCID, you will have absence of T and B lymphocyte. Also, DiGeorge syndrome. DiGeorge syndrome has atrophy of which portion of the lymph node? The paracortex. Good. Now I'm going to ask a tricky one. Which portion of the spleen is atrophied in DiGeorge syndrome? There is no paracortex in the spleen. Okay, the white bulb. Excellent. The white bulb, which inside of it also we have this periarteriolar lymphatic sheaths, which contain the what? It contains the T cells. Yes. Okay, so thymoma, it's basically a neoplasm of the thymus. It's associated with myasthenia gravis, which is a disease that leads to motor dysfunction. Basically due to a production of antibody against the neurosynaptic cleft, which lead to motor dysfunction. It can also lead to superior vena cava syndrome, in which it occludes your superior vena cava. So let's take a look at that. So your superior vena cava, normally it drains blood from your head to your body. If it's occluded by a tumor, it will not be able to. Yes, thymus is only in young people. Yeah. So you can see here the tumor, but you're like, whoa, so this is, can a thymoma occurs in an adult? He has an involuted thymus. Yeah, it becomes superiorly atrophied. It has fibrous tissue inside of it, but you still have some latent cells that can develop tumors. But also, not only thymoma tumor can lead to superior vena cava syndrome, lymphoma can lead to superior vena cava syndrome. Any type of mediastinal cancer can lead to superior vena cava syndrome. Okay, so remember this patient. Well, look at this guy. He's trying to drain the blood down his superior vena cava, but he can't. So he has a flushing of his face. If he raises his arms, imagine if he raises his arms now. If he raises his arm, more blood will be going to he wants to go here, but he cannot. So it will go back to his face as well. Okay? Yes, thymoma can be after 20 years old. Okay, so thymoma can be all over your life, basically. Okay, so also we have something called pure red cell aplasia, in which you will only have absence of RBCs, but the lymphocyte and the platelets will be normal, and good syndrome, in which it's a form of immunodeficiency that we will describe when we discuss primary immunodeficiencies. So let's speak about the last thing for today, which is innate versus adaptive immune system. So when you think about the innate immune system, I need you to think about your local police officers. And when you think about the adaptive immunity, I want you to think about special forces, okay? It's an army. So speaking about the innate immunity, its cells were basically your local police officer. They have no clue. So neutrophils, macrophages, and monocytes, dendritic cells, natural killer cells, and complement physical epithelial barrier and secreted enzymes. This is stuff you are born with, correct? They are not modified. You are just born with this set of stuff, and you are like, just deal with it. This is your local police officers. You have to deal with it. They will not learn. They will not understand anything in you. They will just be there, and they are not specific. They are stupid, basically. So speaking about the neutrophils, neutrophils and macrophages, they like to eat. And monocyte, what is the difference between monocyte and the macrophage, guys? What is the difference between monocyte and macrophage? Monocyte, it's when it's inside of the vessel. When it goes to the interstitium, it changes its names and it becomes a macrophage, okay? So inside of the blood, it's called monocyte. When it goes inside of the tissue, inside of the interstitium, it becomes macrophage. Okay, so basically these guys, so far, we know one thing about them. They are stupid. So the mechanism is they are germline encoded. You just get them with your genes and you get them from your parents. It's just the set that you get and you cannot do anything about it. For example, your skin, you don't choose it. It comes with you. So the barriers, the enzymes secreted, guys, there is enzymes secreted from our saliva that protects us from a lot of infections. Also the acid in your stomach protects you from infection. Complement, mucosal layers, all of these are non-specific protectors for your body. So the response to pathogen is non-specific, it works on everything. And it occurs rapidly, minutes to hours. Why? Because it does not require any time for recognition. It works on everything, okay? But it has no memory response. That's the bad thing about it. Because why? It's your local police officers. They just deal with regular stuff. They don't go specifically after the exact reasons, the exact stuff. It's not like adaptive immunity, your special forces. And it can have secreted proteins, including lysozymes, complement, C-reactive protein, defensin, and cytokines. Well, basically, these stuff are produced systemically, which can protect your body against infections with various mechanisms. For example, if we speak about the acute phase reactant, they can decrease the amount of substrate available for the bacteria, which means less substrate available to the bacteria, there will be less maturation of your bacteria. No, well, not your bacteria. You hate the bacteria. You don't want it. Okay, so there is key feature in pathogens recognition. How does the innate immune system knows that, okay, I have a pathogen and I have to kill it? You know, there is something called the toll-like receptors. It's a pattern recognition receptor that recognizes the BAMPs, which is pathogen-associated molecular pattern. And let me explain what does this mean. Well, basically, if you have a bacteria, it has this BAMPs on it, okay? So this is the BAMPs. This BAMPs can be recognized by what? By something called the toll-like receptor. So this is the T, this is toll-like receptor. Look, it's toll, and it's T-like receptor. So, and that is located in your innate immune system cells, like macrophages, yeah? So this is your macrophage, and he has this toll-like receptor. So these two will interact with each other. When they interact with each other, the macrophage inside of it will start activation of something called NF-kappa B, okay? This NF-kappa B leads to recognition of that there is an inflammatory disorder and lead to secretion of cytokines, which initiate inflammatory state, okay? So again, your bacteria, this is your bacteria, it has BAMPs, which is pathogen-associated molecular pattern. They interact with the toll-like receptor, and these will lead to NF-kappa B activation, which lead to more cytokine production. Examples of BAMPs include lipopolysaccharide in a gram-negative bacteria, the flagella of the bacteria as well. Also, nucleic acid in case of viruses, for example. Well, viruses do not contain lipopolysaccharide. They don't have a flagella, but they do have a nucleic acid, which can be recognized with the toll-like receptors. And that can lead to activation of NF-kappa B, which lead to the production of a lot of cytokines that can protect your body. Okay, of course, this response is highly nonspecific. This is your local police officer. They are nonspecific, but they are good. You are born with them, you know? The adaptive one, this is what all vaccination is all about. So adaptive one is your FBI, it's your IRS, it is your special forces. So adaptive immunity, we have the T cells and the B cells and circulating antibody. These guys are highly specific. They know exactly what they are doing. So there is something called the VDG recombination. To explain what is this VDG recombination, you need to know what is an antibody. So we have something called VDG recombination. Well, basically, you have something called the variable region, which is located in your antibody. This is an immunoglobulins. It has this area. This is, we call, a variable region, okay? That variable region will be made, actually, by the process of VD recombination. The VD recombination process, I will be explaining for you the next class. But to make it short, you need to know that this process occurs differently in each one of us, according to which microorganism are we exposed to. This adaptive immunity is highly specific, and it's refined over time to fit exactly your need. It develops over a longer period of time, and memory response is faster and more robust, which means, I told you, they are your special forces. Well, special forces versus your local police officer. Your local police officer, they are lazy, ate a lot of donut, and yeah, they don't do a lot of stuff. Your special forces know exactly who their enemy is, know exactly when they should start working, and they work as fast as needed. They include your immunoglobulins, So the proteins secreted that are concluded in this, guys, we have the immunoglobulins, which are made by the B cells, yes, and cytokines, which are made by T cells, okay? So memory cells, which are activated B and T cells. Subsequent exposure to a previously encountered antigen lead to a stronger and quicker immune response. This is what we learn in school, guys. Basically, if you have an immune cell, okay, and you give it a form of a weakened virus, okay, she will take that virus and be like, yummy, okay, he's weak, I like him. Let me do antigen representation for it, and let me tell the body, let me tell the plasma cells to make a lot of antibody against it. So next time he will enter the body, this is a plasma cell. Next time he will enter the body, he will come. The moment the antibody will see it, he will be like, I see you, come here. So it will attach to it, and the macrophage will be like, yummy. He will go and eat it. So as you see, we have developed a memory cell. The same with the T cells. It also can develop memory against the pathogenic infection. And yeah, that's what I wanted to describe for you today. So we discussed 4 pages. I know that 3 out of 4 were easy, so yeah, or moderate, but this page, I know, it's hell. You need to print it and put it somewhere, because this is a pure memorization. I'm sorry. Please remember about the mastitis and the syphilis one. Okay, and that's it for today. I will meet you tomorrow. No, tomorrow is actually our vacation day, but I will open a poll about that, because I'm planning to start taking the vacation day either on Saturday or Sunday. But after all, it's your opinion, guys. It's what you decide. So yeah, we have to agree on that together. I will open a poll about that and we'll decide that. And yeah, until next class we will discuss these 4 pages, which are super important. And after that, we start with immune responses. So see you later, guys.